In this second video of day 25, I want to practice with two more trinomials. In each case, the trinomials have c values that are less than 0 or negative. When we're factoring these trinomials, we must first find factors of the last term. In this case, we have factors of negative 24 that we're looking for that also sum or add to equal a positive 2. So let's start off by listing these factors. We can use a negative 1 and a positive 24, or a positive 1 and a negative 24. We have the option of using 2 with negative 12 and negative 2 times positive 12. We could also use 3 times negative 8, or negative 3 times positive 8. Lastly, we have the option of using a number 4 with negative 6, or negative 4 with positive 6. These are all the factor pairs of negative 24. We need to verify those that add or sum to equal positive 2. And in this first case, we have a sum of 23. In the second case, we have a sum of negative 23. Next, we have negative 10, then positive 10, negative 5, positive 5, negative 2, positive 2. That's the sum of all of these factor pairs. Only one works, however, to sum to a positive 2, and it happens to be the very last one that we investigated here in this set. The only pair of numbers that multiply together to equal negative 24, but also add together to equal positive 2, are the numbers negative 4 and positive 6. So we say that this factor pair, or this trinomial, factors into the pair of binomials that utilizes the factors of positive 6 and negative 4. And since this is a standard trinomial, the two numbers that multiply together to equal our lead term are x and x. So we would say that this trinomial factors into the pair x plus 6 and x minus 4. Let's look at another example. In this example, we must find factors of negative 18, because that's our last term in this trinomial. And these factors must also sum to equal negative 7. So the first pair of factors that I can think of would be a positive 1 and a negative 18. Then we might have a negative 1 and a positive 18. We could use a positive 2 and a negative 9, or a negative 2 and a positive 9. Also, we might use a positive 3 and a negative 6, or a negative 3 and a positive 6. When looking at the sum of each of these factors, 1 and negative 18 sum to make negative 17, negative 1 and positive 18 sum to make positive 17, negative 7, positive 7, negative 3, positive 3 are the last sums. We're looking for numbers that sum to make negative 7, and most of these do not work. However, there is one option that does, and that's utilizing the factors 2 and negative 9. So in this case, we would say that the factored result of the trinomial n squared minus 7n minus 18 is equal to the binomial pair x plus 2 and x minus 9. We could double check our work by foiling this back together. Let's go ahead and do that. The first product is x squared. The outside product is negative 9x. The inside product is 2x. And the last product is negative 18. These two center terms are like, so they can be added together. And we have x squared minus 7x minus 18. This end result checks out, so we know that our original answer, x plus 2 times x minus 9, is a perfect solution to the factors of x squared minus 7x minus 18. Tomorrow in class, we're going to work on problems from section 8.1 again. This time we'll look at numbers 7 through 14 and the numbers 15 and 16.